Hello everybody. Welcome to this tutorial that is part of Computer Science Education Week 2020. My name is Jay. I'm a programmer and an educator, and Computer Science Education Week has for a long time been one of my favorite times of the year. In this tutorial, I'm going to show you how to create a game using the JavaScript programming language and a library for game creation called Phaser. And because I want to keep things moving pretty quickly, I'm going to get right into it. So, first thing I want to do is give just a couple quick credits. So, as I said, the library we're using for making the game is called Phaser. You see the URL right there. It's very useful. It makes making a game quite easy, as hopefully you will see. So it's a great tool. I am no artist, so for the art resources we're going to use in this game, I've taken some from an artist named Kenny, who is very generous about sharing his art for game creators to use, but wanted to make sure I gave him credit. So, in order to do this tutorial with sort of a minimum of investment on your part, not requiring you to install anything, we're going to use a resource provided by the good folks at Phaser called the Sandbox, which is a little tool, and we'll look at it quickly now, for writing Phaser games. You see there's a place to write your code there on the left, and then run it on the right, and you'll see the game on the right. And so the sandbox is what we're going to use, and that way you can just type in your code and you don't have to install anything. Speaking of which, here is the link to the code that we're going to be using. That is just a little template, and we're going to be adding things to it to actually make the game work. So the first thing we're going to need to do is copy the code from that link there into the Phaser Sandbox. So let's do that now. Alright, so we're here in the Phaser Sandbox. I have the template here in this other tab. I'm just going to select all by dragging. You could also do Control A on most computers, and then right click and choose copy. You could do Control C. Coming back to the Phaser Sandbox tab, I'm going to delete the code that's already there and do right click and oops, I've got a different menu there. I can't do right click, so instead I'm going to do Control V to paste. And so there it is. Our code is in place. That is a sample code we're going to be starting with. So let's take a quick look at this code, then we'll come back and take a closer look. So at the top we've got some variables, it looks like, title of the game, maybe there can be other stuff up here later. And then another variable that represents the configuration of Phaser. This line is going to create the Phaser game object that runs everything. And down here we have three functions, preload, create, and update, that right now don't do anything. Let me just show you a quick little flow chart about how all that fits together. So the game starts, it runs our configuration code, then when we create the Phaser object, Phaser takes over. That's what this blue box indicates, that from here on out, Phaser is sort of doing all the steps, but then it calls code that we write to do individual jobs. So the preload function that we write will download pictures and sounds from the server. The create function that we write will actually create the game world, all the scenery and objects and characters in it. And then the update function gets run over and over again. There's this little loop here. So it gets run over and over again to actually carry out the game, to redraw the scene, 60 times a second, to respond to controls and make the animations happen and all the things like that. Alright, so let's go back to the code window and look at the code in a little bit more detail. So this top section is a good place to put any variables that you might want to use throughout your game's code, to configure it or to set up defaults. Right now all I've got here is the title, which is not really strictly useful, but later on we'll do something more meaningful with variables in this area. The next section is more important. The Phaser system requires a configuration object. This is what's called in JavaScript an object. And the format is kind of like an index card. If you ever seen an index card, maybe to represent, data about a person, it has some fields like name, colon, then the person's name, age, colon, the person's age. It's the same idea here. The part to the left of the colon is called the key, and the part to the right is the value. The key is kind of a label, and then the value is just some data. So this is a way of collecting data together with labels for individual parts. In this configuration object, type should always be Phaser Auto. That basically tells Phaser to use the best graphic system available. Title is the title of the game. Notice this references the variable from above. Width and height are the width and height of the game window. Physics. So many games you want to have the characters and things behave in realistic ways. Like if something's in the sky, you want it to fall. So you have to write code to make that happen. The computer doesn't automatically know how to make that work. But game programmers realized a long time ago that it doesn't make sense to have everybody rewrite that same code for falling and other things like that every time. So they collected those tools and rules together in what are called physics libraries that implement things like gravity and stopping things from running into each other or stopping things from passing through each other when they do run into each other. And so we're going to use a physics library built into Phaser called Arcade. Then, this next thing is very important. This scene property, which itself contains an object that has three other properties, is what links Phaser to the three functions we're going to write that I referenced earlier when we looked at the flowchart: preload, create, and update. Again, preload loads the images and sounds and things we're going to use from the server. Create actually creates the game objects and adds them to the game world. And update runs over and over again to actually run the game, to move the characters around, and do things like that. Once we've got this configuration object set up, we can actually create the Phaser game. So we're creating a variable here called game. New creates a new object. The type is a Phaser game object, and we're giving it the input that is that config variable we just created. So at that point, Phaser takes over, but now it's going to start calling the functions that we write. So let's look at this preload function. As I said, the preload function is going to download the images and sounds we need from the server. The first command that's already in here actually sets the server, the location that we're going to download from. Right now, this is my server that I've got the resources for this game already set up on. If you're working as a programmer for a game company, for Facebook or Google or Electronic Arts or whatever, this would reference their server, facebook.com or whatever. But right now we've got resources on my server for this game. Let me show you real quick. The character in this game is going to be based on this little guy created by Kenny. Guy or girl, I don't know. Looks like a little handheld game computer. So these are some of the images we're going to be using. Eventually, we're going to use all of them and put them together in animations. But for right now, we're just going to use this one called idle, which is basically just him standing still. So let's go back and see how that works. To actually download it, we're going to do this .load. Oops, I think I did .load .image. And then we need to give it a name. It can really be anything. I'm going to call this character TM. And then we actually have to give the path. And so the path to this is going to be assets, PNG, characters, idle.png. And then semicolon. Now, if we run the game at this point, nothing happens because although we have downloaded the file from the server, we haven't given any instructions for actually putting it on the screen. The code to actually put the image on the screen is going to go in the create function. Before we go there, I need to talk about this section we skipped over called global variables. I don't want to get into a lot of detail about this. Global variables are variables that are shared by all the functions in a computer program. Most of the time, people are going to tell you that using global variables is a bad idea because it makes it hard to keep your program organized. And that's true. And for larger projects, that's something you should pay attention to. And there's other ways to organize your code that doesn't use as many global variables. But for us, for right now, global variables make it easy to share data between functions, and we need to do that. The variables we create in the create function need to be accessible in the update function. So we're going to create a global variable here, and later in the tutorial we'll create a few more. So I'm going to say let tm. That just creates a variable and makes it global. We're not going to give it a value yet. We're going to give it the value in the create function. So here we're going to say tm, not let, because we're not creating a new variable. We are going to actually use the variable, the global variable we just created, equals, and then this physics add sprite, and then this is going to take three inputs, three arguments. The first two are going to be the x and y coordinates where we want it to show up, and for right now let's just say 100, 100. And then the third one is the name of the image to use. Well, we just gave the image of tm the name tm, so we'll say that. All right, and then let's look and see what happens when we run this code. And there it is. TM actually appeared on the screen. Doesn't do anything. He's not falling or anything because although there is physics in our game, we haven't added any gravity yet. But there he is. Before we move on, I want to talk about a couple other things. Let's look a little bit more closely at this command. So this is a variable that gets passed to all our functions, basically to give it access to all of the Phaser capabilities and tools. So using this Phaser toolbox, we're going to use the physics tools. One of them lets us add something. What are we adding? It's called a sprite. The individual objects in our game that move around and interact are called sprites. And then the inputs already talked about, the x and y coordinates, and then the reference to the image we downloaded. Okay? So that's how that command works. Now let's talk about these coordinates, and to do that we need to look at another slide. So in math you probably learned about x and y coordinates. The x comes first and it represents left and right. The y comes second and it represents up and down. But in math you learn that the x and y, when x increases in the positive direction, that goes to the right, and when y increases in the positive direction, that goes up. In computer graphics, it's different. The x is the same, it still goes to the right, but in computer graphics, y increases going down. So in our screen that is 800 by 600, 0 zeros in the upper left, 800 0 is all the way to the right, and 0 600 is all the way down. So of course the lower right would be 800 600. So it's important to keep that in mind. It's a little bit different than what you're used to seeing in math. So when we placed TM at 100 100, that meant go over 100 from the upper left and down 100 to right here. And so that's this little spot right here that's kind of but not quite in the center of TM. The reason it's not quite in the center is because the image file that makes up TM actually is a square and it has some empty space at the top. So if we could see that square, we'd actually see that this yellow dot is at the center of the square, even though the image of TM is a little bit lower. So that's how that works. All right, so let's go back to the code. Well, I just made a big deal about how Phaser has a physics system that handles things like gravity, but as we just saw and actually are still seeing, doesn't look like there's any gravity going on in this scene. So let's actually add some gravity and see how the Phaser system makes that work. So I'm going to skip a line and do this dot physics dot world dot gravity dot y equals 200. So very quickly, this is the Phaser toolbox. Physics is the physics system. This is going to affect our entire game world. It's the gravity part of the game world, and it's in the y direction. One kind of cool thing is, unlike in the real world, in the Phaser world, we could, in theory, have gravity come from any direction, not just down. But we're going to keep it simple right now and go down. And remember that in computer graphics, down is a positive y coordinate, so positive 200 will make our objects move down on the screen. So let's see what happens when we run that. Hey, it worked. Unfortunately, he kept falling off the bottom of the screen, which is probably not what we want. So we need to make another change to fix that. And let me show you how to do that. So we'll come back over here. And we'll make this part of TM's code, because it's actually going to affect just TM. We're going to use a function called setCollideWorldBound. So tm.setCollideWorldBounds true. So this is a function that is part of TM, so it affects only TM, and it tells it, okay, we're actually going to use the physics system to determine when TM runs into one of the edges of the screen, and just like it was a brick wall there, make him stop. Okay, we're going to see it from the falling now, but later on when we let TM move left and right, we'll see that he can't move left and right off the edges of the screen either, because once we've run this command, it's like there's walls around the screen. See? Worked. Alright, let's move on to the next part. Right now, TM's world is pretty boring, so let's add some scenery to make it more interesting. And in order to do that, we're going to use some more art from Kenny. So I have these tiles that Kenny created on the server. We're going to use several of them over the course of the tutorials this week, but just one today, this first one, tile 001, to represent the ground. One thing to understand about this is these tiles are 64 by 64, and that's kind of going to affect how we build our game, because it makes sense if we're going to build a game world out of these tiles to build the world in a grid that's got 64 units on each side of each square. So what we want to do is think about how all that fits together. So for example, we want to make a game world that looks kind of like this, where there's a bunch of squares, each 64 by 64. We'll put the ground at the bottom. Other objects we create we'll want to keep aligned with these boxes. And notice that the coordinate system implied here is still the same as before. 0, 0 is in the upper left, and then X is increased to the right, Y is increased down. The example we're going to use, we're going to go 12 squares across and 9 squares down. And here we're going to use this idea and return to those variables we had at the top of the code and see how they can make things a little bit easier for us. So now we can see how this variable section at the top of the code can be useful. Remember, I just said that each tile was 64 by 64. Let's actually create a variable to represent that. So tile size equals 64. I'm using the const keyword to show this is a variable, but it doesn't ever change. And knowing it doesn't ever change, the computer can be a little bit more efficient in how it uses it. If we said let here, it would work just as well. It'd just be slightly less efficient. And then let's also create variables for the number of tiles going across and the number of tiles going down. So I'll call that grid width, and I said that's going to be 12, and grid height, that's 9. Now let's come down to where we set the actual width and height of the screen. Well, this should be in pixels, not in tiles. We can figure that out using math, and we don't have to figure it out. We can let the computer do it. Since each tile is 64, the width is going to be the number of tiles times the width of a tile. So that's grid width times tile size. And the same for the height. It will be grid height times tile size. I think I misspelled that there. Tile size. And so now we have our size of our screen set up so it's a perfect size to fit 12 tiles going across and 9 tiles going down. If we run the code again, you should see a slight change in the size of the screen. It's got a little bit smaller. We can also see, or maybe it's not entirely clear here, that TM is bigger than a tile. It's probably not obvious actually from here, but TM is 96 by 96 instead of being 64 by 64. And things will work better if we make TM the same size as the tiles that make up our scenery. So let's change that as well. So we're going to come down here, back to create, and add another command to TM. We're going to say TM dot set display size. So it just changes the size of TM. We got to give the new width and height, so 64 and 64. And we need to do one other thing as well. The graphic system and the physics system in Phaser are not directly connected. Just because we change the size that TM looks like doesn't mean the physics system understands that TM is now smaller. And so if we just left this and didn't do anything else, even though TM was going to look smaller, when it comes time to see if he runs into things, it's going to check for collisions as if he were a bigger character. And that's not what we want. So we want to update the physics to match the appearance on the screen. Fortunately, there's an easy command to do that. If I do tm.refresh body, that says, do what I just said. Update the physics to match the appearance on the screen. So now if we run it, it's the same, just with a slightly smaller TM. So now that that's done, we're ready to actually add the ground to the screen. So we need to preload that file. So in the preload function, this load image, just like before. Give it a name, we'll call it ground. And we need the path to it. Assets, PNG, tiles tile 001.png. Now the actual adding is going to go in the create function, but as we did with TM, we need a variable to hold the things we're adding. So we'll put that up in the global variables section. I'm going to call the variable platforms. And now we're to see something a little bit different, because instead of just adding a piece of ground directly, we're going to do it in kind of an indirect way. We're going to say platforms equals this dot physics dot add, and we're not going to add a sprite, we're going to add what's called a static group. So platforms right now is not our ground. Nothing would display, nothing new would display if we ran the program. What we're going to do is we're going to use this as a group to hold lots of individual pieces of ground. Every piece of ground on the screen should act the same way. And if we didn't do it this way, we'd have to write a bunch of code for each individual piece of ground to make it behave the way we want it to. By putting it in a group, we don't have to duplicate that code. And because it's a static group, that means it's not going to move. So it's not going to respond to gravity. It's not going to move when something bumps into it. So that's perfect for scenery. Then the actual command for adding an individual piece, an individual image to a group is similar to the add sprite. So it's platform create, platforms create, and then the variables are the same. It's the x and y coordinates and then the name of the image to use. So for right now, I'm going to say 200, 200, and then ground. That's not actually where we want the piece of ground to be, but for a moment we'll see what happens. So if we run this now, well, there we have a piece of ground floating in the air. Not where we want it, but it's a start. All right, now let's figure out where the coordinates of this tile should actually be. We want the first tile in the lower left-hand corner. So let's go back to our picture of the grid and see what that can tell us. Well, at first it looks like the lower left-hand corner would be 0, 576, but that's not quite right, because what we want is to position the tile in the middle of the square. We're giving the coordinates for the middle of the tile, so that's the middle of the square. So 0, 576 is the lower left-hand corner, so we need the middle. Well, the middle of the square is halfway across. Each square is 64, so halfway across is 32. So that would be 32 right there, the x-coordinate. Now, for the y-coordinate, well, we've got to go down quite a ways. We've got to go down. Each block is 64, so 64, another 64, another 64, another 64, another 64. Looks like, let's see, we're skipping over 1, 2, 3, 4, 5, 6, 7, 8 blocks of 64, and then down half a block to get to the middle. So 8 blocks of 64 plus half a block. All right, so let's see if we can use that in our positioning of the tile. So we'll go back to the code and change these coordinates to, well, 32 for the x. And then we could do the arithmetic, but let's just let the computer do it for us. So 8 times 64 plus 32. Remember, 8 blocks of 64 plus 32 to get halfway through that final block. And now if we run it, hey, the tile is in the right place. Okay, well, that's great, but we want to have, a tiles going all the way across to make the ground. So let's come back and add another tile. So same basic idea. Platforms, create. Okay, well this next one is going to be not in the same position, it's going to move over. Well, it's going to move over exactly 64. So it's going to be 32 plus 64. I'm going to write that as 1 times 64 for reasons you'll see in a couple minutes. And then the y is the same vertical position. So 8 times 64 plus 32, ground, and let's run that. Okay, well, that's pretty good. The tile ended up where we wanted it to, but somehow TM fell behind the tile rather than stopping. The reason for that is we don't necessarily want everything on the screen to run into everything else. We want to be able to have, say, pictures on the screen that just represent backgrounds and scenery that don't actually block our characters from moving around. So unless we tell it to, the physics system in Phaser doesn't deal with collisions between objects. We've got to tell it specifically which objects we want to have collide with each other. So we can do that using one fairly simple command. I'll put it down here near the other physics stuff. This physics add collider, and we need to say the two things we want to collide. So TM and platforms. So this says, okay, physics system, we really do want you to check for collisions between TM and platforms. And this is a good example of why it is good to use a group, because if we didn't have a group, we'd have to do this command for every single piece of ground. But by including them in a group, then this one command covers the collision for all the pieces of ground we've added and that we're going to add. So let's see if this works. And it does. Hooray! All right, we're almost done, but we need to finish making the ground here. So if you recall, when we made this grid, we made it 12 across. So we've got 2 pieces of tile there now. We need 10 more. So we could just add 10 more create statements to make the last 10 pieces of tile, changing the x-coordinate the right way each time. But in computer programming, when you find yourself doing the exact same statement, maybe with just little differences over and over again, that's a good time to think about using a loop. So that's what we're going to do here. I'm going to use a for loop. I think I'm going to go ahead and just kind of type it in and explain after I've got the whole thing written out. So for let I equal 0, I is less than grid width, I plus plus, and then inside the curly braces, platforms, create, and then it's going to be 32 plus I times 64, and then 8 times 64 plus 32, and then ground. Make sure we put it in quotes. And so there it is. Now let's go through how this works. The for loop has 3 parts to this initializer, and then the stuff inside the curly braces is what gets repeated over and over again. So the first part is create a variable and set it equal to some number. So we're creating a variable called I and setting it equal to 0. The second part is a test. Basically, this goes before every time through the loop. It will check to see if the variable I is less than grid width, which you remember is 12. And then this happens at the end of the loop. I plus plus just means add 1 to I. So the loop starts with I equal to 0. Before each time through, we check to see if I is still less than 12. at the end of each loop, we add 1 to I. So eventually it will be greater than 12, greater than or equal to 12. Inside the loop, we're doing the platform create, and look here, look at this expression for x. It follows the same pattern we saw up here, because it's always 32 to get us to that halfway point, halfway across the tile, and then I times 64, so the first tile is, 0 extra steps. The next tile is 1 extra step. By extra step, I mean you have to move over 64. And so we're multiplying this loop counter variable times 64 to go over the right amount. Really, I should be using these variables here that we created for the tile width and even half the tile width for the 32. But to keep things a little bit clearer and less abstract, we'll just leave those with the numbers. The only other thing I want to do here is this is going to create all 12 of the tiles. So we don't need these 2 that I created by hand before. So we can remove this. But instead of deleting them, if you put 2 slash marks in front, that turns the whole line into a comment. So that's something that humans can read, but the computer completely ignores. And it's a good idea when you're coding and debugging to, instead of deleting code you don't need, to comment it out, to just make it into a comment. That way, if you change your mind, it's easy to fix just by removing the comment characters. Later on, if we really want to clean this up, we can remove it. But for right now, while we're testing, let's leave it as a comment and see what happens. And there it is. There's our full ground going all the way across. All right, I think we're going to stop here. This has already gotten to be a pretty long video. I hate that we're not going to get to make our character move yet, but we'll get to do that first thing tomorrow, and we'll also add some animation and some other platforms and things like that. So please come back here tomorrow to see the next part of this, and thanks for watching.